decimal representation of rational numbers. So we know that every rational number we can express as decimal number, or every decimal number we can write as a rational number. So but every rational number can be expressed either a terminating or non-terminating decimal. So we have the two cases. First one, what is terminating? So these two words meaning we should know. So terminating decimal. So when you come to these terminating decimals, so every rational number can be expressed either terminating or non-terminating. So when you come to this terminating, for example, 1 divided by 8. If you do the division of this, you'll get 0.125. Okay, let us say one more example, 1 divided by 25. 1 divided by 25 do 0.04. Even in mixed fraction, 3 2 by 5. This is a 3.2 by 5. It's 4. 5 4s are 20, right? So okay, 3.4. Now when you observe these examples, so here is in each example given the above, the division is exact. That means there is no remainder. So no remainder is left, and the quotient is this type of examples. So such divisions are called terminating decimals. So there is no extending and there is no remainder is left. That means we got remainder 0. For every case remainder is 0 only. There is no extra other number. And division is exactly, and it stopped after certain steps. The division is stopped. It's not continuously going. So this is called terminating decimals. It's terminated. So it stopped. You can remember in that way. And one more is non-terminating decimal, the opposite of this. So non-terminating decimals. When you come to this one, here the previous first example is after doing certain steps, remainder is got 0. That means no remainder is left except 0. But in this one, for example, you take 3 by 7. You do division, 3 divided by 7, you will get 0.4 continuously. You can use the calculator or you can do it first. So you will get 0.42857142 so on. It is continuously, it repeats. There is no stopping at all. And 18 divided by 23. So do division, you get answer for this 0.7826086 so on. Without having certain value, it's keep on going. So that means in such example, the given above, the division never ends. So there is no end in the division, and no matter how long it continues. So it continuously, its end. There is no end, and it continuously forever. That means these type of examples non-terminating. So there is no stopping. There is no terminate. So it's keep on repeating, keep on going on. This means there is no remainder 0. That means obviously it's non-terminating. Okay, this is one. And along with this terminating and non-terminating, in non-terminating we have another case, non-terminating recurring decimals. Recurring. Let us see what is this. So non-terminating, and one more word you can use, recurring decimals. So when you come to this recurring decimals, let us take one example, understand clearly. 4 divided by 9. If you do division of this, you will get 0.444 continuously. 11 by 30. Take one example. I am not doing division here, directly I am writing answer. 0.3666, it repeats. In first example, this digit 4 is repeated again and again, and in second example, there's 3. 3 is not repeated, but 6 is repeated. So some set of terms, set of numbers, if repeated continuously, they are come under non-terminating recurring decimals. So they are recurring. So we can use periodic in the instead of word this recurring, periodic or circulating decimals, circulating or periodic. Okay, all are same. No need of getting confused. These type of examples will come under this. Okay, let us see one more. 13 by 44. 13 divided by 44. 0.29545454. So here is a 2 9 is not repeating, only this 5 4, this is repeating continuously. So this we can write 0.2954, which is repeating. On that we can keep on hyphen, one bar. That meaning is that only repeats. Here is a 0.36, only on the 6 we can keep the bar symbol. 0.4, so which one is repeating, which set is repeating, or which set of numbers are repeating, on that we need to keep, right? These are the non-terminating recurrent decimal or non-terminating periodic decimals, non-terminating circulating decimals, non-terminating but extra same set of numbers are repeating. These come under recurring. Okay, these are the examples in this. Let us see now. These are only some of the topics you studied in previous. Let us see, start with the irrational numbers and properties also.